Greetings, fellow grade 11s. It is your favorite tutor, Mr. Shajari here. Welcome to Back to Basics, right? Now, what we are doing now, for an example, in this particular video, we are going to be looking at a past paper which was written from the KZN province, and this was from the year 2024. I think this was our March paper, right? So we are looking at different types of questions that we may get in our examination when it comes to exponents and sets, right? So let's start now from here. What is this? All right. Now, what is going to be this one for an example now here? So we are saying now from here, we are looking for what? Now we are saying this is 64 to the power of negative 2 over 3, right? Now, so what is it then that you can do now from here to find out now this one, right? To solve this one. Remember, let's look at the exponent. Can you see that the exponent here, it's negative, right? So to change the exponent from negative to positive, I am going to write this as 1 over, this is same as 64. This is to the power of negative 2 over what? Over 3. Are we together, right? And now what is it then that I can do now from here, right? So now what I can do now from here is that now, for an example, if I look at this, right? This is now positive, right? Remember the reason why I was doing this so that I can change this to a positive. Are we together, right? So this is positive, which means this is 1 over 64, right? Now I can write this back as what? As radical roots, right? Remember now, let's say for an example, we have 1 over, let's say this is same as, let me just do this. Let's say you are having your root of what? Let's say you're having x to the power of n over m, right? Now, remember, this can be written again backward in terms of what this is going to be same as x. Now, this is going to be m, and then this is going to be to the power of n. Are we together, right? So then now, which means that's the same thing that we are going to be doing in here, right? So which means now from here, this is going to be 1 over. Now, what is going to be the 64 for an example here, right? Now, which means now I can come back and say my 64, this is going to be same as 64 squared, and then this is going to be my cube root altogether, right? Now, I want to do this, right? Now, what is going to be my cube root of 64, therefore, when I'm doing it like this, right? Now, my cube root of 64, in this particular case, it's going to be same as what? My cube root of 64, this is going to be same as 4, right? So, which means this is going to be the square root of 4 squared, right? This is going to be what? This is going to be not rather a cube root. This is going to be what? This is going to be same as 1 over 4 squared. Are we together, right? Because now I am saying what is the cube root of 64, which is going to be same as 4, right? And then now from here, this is going to be same as 1 over 16, which is going to be the solution that you are having in here. Are we together, right? Now, and you must remember the reason why I am using this particular approach, it's because here it is boldly stated that no calculator must be used. Okay, right? So now let's look at then the next question. Now in the next question, we are doing 2.1.2, right? What is it then that you're having here? This is same as 3 to the power of 2n plus 2. This is same as 2n plus 2. This is going to be subtract. This is going to be 9 to the power of n subtract 1. Now, this is going to be divided by, right? Remember, this you are given by 2 multiplied by 3 to the power of 2n plus 1. Now, what is it that I can do now from here for an example? Now, I can start by what? Now, I want to find out what are going to be the prime factors of 9, right? So, and I know that my 9 is same as 3 squared, right? So, which means that's where I am going to start, right? So, this is going to be same as 3 to the power of 2n plus 2. This is subtract. This is going to be same as 3 squared. This is to the power of n subtract 1. Now, this is divided by what? This is divided by 2 multiplied by 3 to the power of 2n plus 1. Altogether, right? And now from here, what is it then I can do now? Now, I want you to look at this. Remember, this 2 here, it's applicable here, and this 2 is also applicable here when we multiply back, right? So I want to write these in factor form. Right? Now, when I write this in factor form, what is that I mean when I'm doing that, right? I am saying this is same as 3 to the power of 2n multiplied by this is same as 3 to the power of 2. This is going to subtract what? This is going to be same as what now? This is going to be 3 to the power of 2n multiplied by this is going to be 3 to the power of negative 2. Out again. Now, what is it that I've just done in here, right? So basically here, I've just multiplied the 2 with the negative 1 in here, out again, and also with the n, right? So that's what I've done in here. Then now again here, I'm left with 2 multiplied by 3 to the power of 2n. This is going to be multiplied by 3. This is to the power of 1. Oh, it's okay. And now what else then I can do now from here? Now from here, I can now start and say, look, now from here, I want to take out my common factor between the two, right? Now, if I take out my common factor, this is going to be same as 3 to the power of 2n into bracket. This is going to be same as 3 squared, right? Subtract, this is going to be what now? I can get rid of this to the power of negative 2, right? How can I do this? This is same as 3 to the power of negative 2. Altogether, now this is divided by, again, now I can still write this as 2 multiplied by 3 to the power of 2n multiplied by 3 to the power of what? This is 3 to the power of 1. Are we together, right? And now what is this going to be now? Which means these and these are going to cancel. 2 multiplied by 3, this is 6, right? So what is the numerator that I'm going to get here? Remember, 3 squared, this is same as 9, subtract 1 over 9, divide by 6. Are we together? And now what is it then that I'm going to get now from here? Once again, now that I've done that, now what is going to be 9 subtract 1 over 9, right? Now 9 subtract 1 over 9, can you see that this is going to be same as 8 over 9 if I'm not mistaken, right? Right? When I do my 9 subtract 1 over 9, this is going to be same as your 80 over 9. Altogether, yes. So which means this is going to be same as 80 over 9. This is now going to be done with what now? Remember, I can change the division sign into multiplication sign, but if I'm doing that, this is going to be now 1 over 6 altogether. Now I'm going to say 1 multiplied by 8, this is 80, right? And then when I say 9 multiplied by 6, right? 9 multiplied by 6, when I do my 9 multiplied by 6, this is 54 if I'm not mistaken, right? 54, right? This is 54. And now after that, what else then now I am going to do? Now I am going to divide both sides by 2 because those numbers are divisible, right? So which means this is 40 over, this is going to be 27. Okay, so basically that's what I am going to have in this particular, in this particular expression, right? So let's move swiftly along into the next question, right? Now let's just make up our space here quickly so that we can do the next question that we are given, right? Out again. Now let's look at then the next question and see what is it then that we can do from here in the next question. Now from here, let's see the next question. What is it that you are having here? Now here you are having what? This is same as into bracket. This is same as 3 subtract. This is root 3. This is squared. This is divided by what? This is divided by root of. Now this is root of 3 multiplied by root of 6. Now I want you to have an understanding of this, right? So firstly, the first bracket, what is it that we can do now? Remember these are two brackets of the same thing, right? So which means I am going to start here. This is same as 3 subtract root 3. And this is same as 3 subtract root 3, right? And then now this is divided by, right? Now I want you to look at this, right? Remember when I have my root of a multiplied by my root of b, this is same as what? This is same as square root of what? Of a multiplied by what? Multiplied by b, which is going to be the same thing here, right? So which means this is going to be same as my root of 18 if I'm not mistaken, right? Are we fine, right? So this is, oh, now before I do that, let me just leave this as it is for now. This is going to be same as 3, root 3 multiplied by root 6. Before, let me just check my numerator firstly and see what is that I'm going to have, right? Now 3 multiplied by 3 is going to give me 9. Then 3 multiplied by negative 3, negative root 3, this is going to be negative 3 root 3, right? This is going to be also negative 3 root 3, which is going to what? This is going to be same as negative 6 root 3. Are we together? And now from here, what is it that I'm going to have now in this other one? Now, when I say root 3 multiplied by root 3, negative root 3 multiplied by negative root 3, what is that I'm going to have here? This is positive. If I'm not mistaken, this is going to be positive 3, right? This is positive 3. And then now I am going to divide this. When I'm dividing this, I am dividing it with root 3 multiplied by root root 6 if I'm not mistaken, right? And now what is it then that I'm going to do now from here? I am going to collect my like terms in my numerator and also in my denominator, right? Now, or rather in my numerator, and what is that I'm going to have here? So can you see that what I'm going to end up having here, this is going to be same as what? This is going to be same as, what is 3 plus 9? This is same as 12. So this is same as 12 subtract 6 root 3. This is divided by what? This is divided by root 3, right? And multiply by what? This is going to multiply by root 3 again. Out again, right? And then now, what is it then that I'm going to have now from here? Multiply by root 6. Then I can take out my common factor here, right? Okay, now I am going to take out my common factor here and see in terms of what is it that I'm going to have here, right? But now let me just work on my denominator, right? Root 3, remember now, if I say root 3 multiplied by, if I say root 3 multiplied by root 6, this I said this is same as what? This is same as root 18. And what is root 18, for an example? This is same as 3 root 2, if I'm not mistaken. Are we fine? Right? So which is what I am going to have here, which is same as 3 root 2. Now from here, which means this is going to be same as what? This is going to be same as 3 root 2. And then now I am going to take out my common factor in my numerator, right? Now, can you see that 6 is common in both of these, right? So when I take out 6, this is going to be same as 6. Now here I'm going to be left with 2 subtract. What is it that I'm going to have here? 2 subtract root 3. Oh, it's okay. 2 subtract root 3, and then this is going to be same as 3 root 3. Are you all fine, right? And then now from here, what else then now are we going to do? Then I think from here, we can see that now the 6 and the 3, they are divisible to one another, right? So which means the answer that I'm going to have here, this is going to be same as 2, right? If I'm not mistaken, this is going to be same as 2. What was the answer here? This was 2. Why am I writing this? This is root 2, right? Now, the answer that I'm going to have now from here, this is going to be same as 2, right? This is going to be same as 2 into, right? Into 2. This is subtract root 3 over what? This is over root 2. Are we together? Right? So, which is going to be now the response which I am going to have here. Are we fine, right? So I am hoping that all of this makes sense, that and now we are in a position to answer all these types of questions. Again, right? Now let's look at firstly your 2.2.2, right? Now, because now from here, let me see, is there anything else that I can do now from here? Let's say, for an example, I multiply by root 2 everywhere, right? So can you see that if I multiply by root 2, now what is it that I'm going to have here? If I multiply by root 2, still this is not going to yield any other outcome, right? Altogether. So which is, this is going to be the response that I'm going to have, right? Now let's just now make up my space, and then let me just look at another question and see in terms of what else then I can do from there. 2.2.1, right? Now, if you look at 2.2.1, what is the data that I'm having there, right? So this is same as root, this is x, this is 32, this is 128, right? Altogether. Now, how do I get rid of the square root, right? We all know that if you have square root of a, this is same as a to the power of 1 over 2, because square root here means this, you have an invisible 2 over here, right? But now in this case, you have a visible x here, right? So which means now, how do we then deal with this one, right? How do we deal with this one? Which means this is same as 32 to the power of 1 over x, right? Is equals to 128. Are we all fine, right? And then now from here, what is it then that we can do from here? Now we can express 32 and also 128 in terms of what? In terms of your what? In terms of any prime factor altogether. For an example, if you can check 32, I think 32 is same as 2 to the power of 5, right? This is 2 to the power of 5, close bracket. This is 1 over 2 again. Then this is equals to what is going to be 128. I think 128 is 2 to the power of 7, right? Out again. And now what is it then that I'm going to do now from here? This was to the power of x, right? 1 over x. And then which means this is same as 2 to the power of 5 over x, right? If I'm not mistaken, this is 5 over x, right? Because when I say 5 multiplied by 1 over x, this is same as 5 over x. This is equals to, what is it that I'm going to have now here? This is same as 2 to the power of what? Of 7. And what is it that I'm going to have here? This is same as 5 over x is equals to what? 7. Why am I saying that, right? Remember, the bases are the same, right? So which means we drop the exponents. Are we together, right? If the bases are the same, then we can drop the exponent, which means now from here we can cross multiply. This is 5 is equals to 7x. Then you divide by 7, you divide by 7, which means your x is same as what? 5 over 7, if I'm not mistaken. Once again, your x is 5 over 7. And now from here, now I want us to look at 2.2.2 so that we can finish up with this particular question, right? Now, so we are looking at 2.2.2, right? Now, here, I want you to listen and listen attentively, right? Now, in here, can you see that you are having what? This is same as x, this is x to the power of 1 over 2. Subtract, this is same as 3 to the power of 1 over 4. Right now, this is subtract what? This is subtract 10 is equals to 0, right? Surely these types of questions, we cannot just solve them anyhow, right? Now, but now I want you to understand that this is actually our quadratic equation altogether, right? Now, this is, however, our exponential equation. But now I want you to look at this, right? Now, from here, I think by now you know that 1 over 4, right? It's same as what? It's same as 1 over 2, rather. It's same as 1 over 4 plus 1 over 4, right? Altogether, right? A quarter plus a quarter, right? It gives us what? It gives us 1 over 2, which means now, what is this, right? So which means basically it makes this to be your quadratic equation, whereby now we are going to open up our two brackets here, right? We're going to open up our two brackets here to now factorize, right? Remember now 1 over 2, this I can write this in terms of 1 over 4, and then where this is also x is equals to 1 over 4 altogether, right? And then now, because we are looking for -3, now we are going to come back to 10 and say, what are the factors that can give us 3, right? Can you see this is going to be 5 and 2, which can give us your 3 altogether. And then now, what are we going to do now? The bigger factor is going to take the sign of the middle term. And then since this is negative, then here it must be positive, so that when you multiply a positive and negative, you get the negative, right? And then now from here, what else then now are you going to do? So which means this is going to be same as x to the power of 1 over 4 plus 2 is equals to 0, or this is same as x to the power of 1 over 4 minus 5 is equals to 0 altogether, right? And then now what is it that we're going to do now from here, right? And then now from here, can you see that this is x is equals to, right? X to the power of 1 over 4 is equals to -2, right? And now from here, there is no way that we can find a solution, right? This gives us no solution. Now, when you continue solving this you cannot actually continue to solve this, right? But now, if you look at this is same as x to the power of 1 over 4. This is equals to what? 5, right? And now, if this is to the power of 5, now what is then you are going to do now from here? Remember, we want to get rid of the exponent in here, right? So which means this here it's going to multiply by 4 over 1, which means here it's same as to the power of 1. This is also multiplied by 4 over 1, right? So which means here your x is going to be same as 5 to the power of 4. And what is going to be this? This is going to be same as 6 to 5, right? X being equals to 625, right? Okay, so basically now this is how we go about whenever we answer these types of questions, right? I am hoping that all of this makes sense, and thank you very much for listening.